This is a bacteriophage, also known as a phage. Well, would you believe me if I told you this is a virus? And not just any virus. It is one of the most lethal viruses on existence. However, even though it's the most lethal virus in the world, causing many non-human deaths, and as dangerous as this may sound, it does not have the ability to affect human cells. It only affects specific bacteria. And it is one of the most common living beings in the world. We can find it everywhere, from a single puddle to Point Nemo, the farthest point from Earth in the Pacific Ocean. We can see it on Earth, in the very air we breathe, and even phages are part of our gut microbiota. The phage is divided in 4 parts. This is what we call its head, consisting of the capsid, which is the other part, and the DNA, which is inside the capsid. Below the head we can see the neck, which connects the head to the tail. The tail is made up of the stealth, which is the entire elongated part below the neck. The basal plate, which is located below the teeth, the spikes that are like syringes with which the phage injects its DNA into the bacteria, and finally the tail fibers, which resemble its legs, are used by the phage to hold onto the bacteria that will be its host. Phages infect bacteria to multiply, this through 2 methods, the lysogenic pathway and the lytic pathway. We start with the lytic pathway. Everything begins from the moment the phage injects its DNA into a bacteria. From that moment, the phage takes control of the bacteria's body and forces it to produce the parts of the phage's body, copying the DNA that the phage injected, which assemble, forming new phage which release a protein called lysine, which causes the bacteria to explode and die, releasing many new phages that can infect more bacteria. Meanwhile, the lysogenic pathway, like the lytic pathway, begins from when the phage injects its DNA. Only this time, instead of forcing the bacteria to produce more phages, what it does is implement its DNA to the bacteria's DNA, remaining inactive, so the bacteria continues to multiply by cell division as it normally would, but with the difference that by copying its genetic code, it ends by copying the phage's DNA until it is activated. It separates from the bacteria's genetic code and switches to the lytic pathway, which, as I already explained, forces the bacteria to produce phages that release lysine, which causes the host bacteria to explode. Now, what makes phages special? Let's take the E. coli bacteria as an example, which causes disease such as diarrhea or urinary tract infections. Generally, the first thing we do when we get sick is take an antibiotic, but this isn't always the best option. Why? The problem with antibiotics is that they not only kill E. coli bacteria, but they also end up damaging the entire intestinal microbiota. This is where phages come in. Phages function as guided missiles that only target a specific bacteria without harming any other bacteria. Now, you might be thinking, so it's just another option to antibiotics, right? But no. As you know, all living beings tend to evolve over time, and no matter how small they are, bacteria are also living beings, so they evolve. So let me introduce you to multi-resistant bacteria. Multi-resistant bacteria are evolved bacteria that are resistant to antibiotics. So if in the past we were cured just by taking an antibiotic, I regret to inform you that in the not too distant future, this will no longer be possible, and all thanks to this class of evolved bacteria. But it's not all bad, because multi-resistant bacteria, in addition to becoming resistant to antibiotics, become vulnerable to phages at a certain point, and phages, being living beings, also evolve, which is why they are the best option we have so far. Although this topic sounds very promising, much research is still needed before it can be implemented in current medicine. but with current technological advances and sufficient effort, it could be implemented in the future, not as a replacement for antibiotics, but rather as a complement.